All right, number 8, someone said? Hopefully I can do it. Okay. Really? How was my day? Good. I went to the hospital and got a lab drawn during my lunch. So, anywho. All right, use the quadratic formula. What?
How was it?
The lab draw? It was pretty quick. It took me longer to get there. But use the quadratic formula to answer questions about the equations. So, looking at 8a, what do we need to do first here? Identify what?
A, B's, and C's.
Okay, but looking at it, is there anything I should try to do first? Okay, do I have a GCF? Yeah.
That's number 3.
This is number 3?
That's 9 for ours.
Oh. Oh. Well, shoot. What's your number 8 then? Really?
It's like graphic cruncher.
Oh. Time test review. Okay. Well, shoot. How'd I do that? I don't know either. Let me see if there's a shoot. You know what? Let me see, because it'll probably be quicker. Is this it?
Yeah, that's a different graph.
It is a different graph? Gosh darn it, it is. Well, what's this? Watch, I'm probably showing you the test. It says review. Ugh. Let's try this again. Unless somebody like, no, I don't want quizzes right now. Shared drives, department. I'm going to see if I can find the right one. That way I won't have to keep guessing.
You should push the test back then.
No. I wouldn't. Quiz, review. Quiz. That's the only one I have. Okay. I guess we'll have to do the hokey pokey and turn ourselves around or something. I don't know. Okay, but it's a different graph, you said. That is weird. So your number 8 is my number 6, but with a different graph, right?
I guess.
That is weird. Okay. I see that it is going. Ah, that is annoying. Is there another one? Let me see if there's another one. No. Wait. What's this one? Is that it? That's not it either. And this doesn't even match the one that I did and worked out. Okay. I don't know. Someone must have changed it. And I won't give any initials, but okay. So I'm going to redraw this graph if I can. Jeez. Actually, looks like it's going here and here. And Autumn, please put the phone away. Okay. So it should go something like this, which is kind of hard to tell, I know. There. Something like that, right? Okay, so this is your number 8, right? This is the one you wanted to see. Who wanted to see this? Allison? You wanted to see this one? Right?
Yeah.
Okay. So number 8. Use the graph to help you find the following. The roots. What are the roots? Look at the blue graph. Anybody, what are the roots? Guys, put the phones away.
0, -1.
0.
What are the roots again? -1 and 5. Yes. So the roots are where the graph crosses the x-axis. Okay? -1 and 5. Now, if they say they want them in ordered pairs, it would be -1, 0, and 5, 0. But it doesn't say it here. I'm just thinking of the last test. It asked for a lot of ordered pairs. Jeez. Factored form. Factored form. Yeah.
That y equals x plus 1 and 5. And x minus 5.
That is correct. So y equals, parentheses, x plus 1 times quantity x minus 5. How did we get those values? If you remember, factored form is y times a times x minus your first root times x minus your second root. So we substitute the roots in, and when you subtract a -1, that's what gives you the positive one. Now, some of you might be saying, oh, but we didn't find a. Use the graph to find it. As I'm looking, a actually is not equal to 1. But if you had to find a, you could look for another value and substitute that value in if we had to find a. I think here, maybe we should have said assume a is 1 or -1. And here, since it's opening upward, we're going to say it's a positive 1. Okay? Is everybody with me? Okay. Vertex. What is, Allison, my vertex? Do you know? Or where would I find it? It's either the highest point or the lowest point. So in this case, it's going to be the lowest right here. This is my vertex. Again, I apologize. I don't know why they're not driving up because I have the same thing you do. So my vertex here is what? Anyone? No. 2, -3. Does it make a difference? Yeah. Yes, it does. If you're in a submarine and this missile is going to this x coordinate and this y coordinate, you better be getting them in the right order, okay? X always comes before y, just like in the alphabet. So, vertex form. Vertex form. Who can give this to me in vertex form? And we are going to assume that a is equal to 1. Who can give this to me in vertex form? Nate?
1 parentheses x minus 2 squared minus 9.
-9. How about y equals? That's pretty close. Not quite accurate. Does anybody have something else? Say it again. I like your a value. I like your h value where you have x minus 2 quantity squared. I don't like the -9. What is this 2 and -3? How else do we think of those?
It's supposed to be -3.
Yes, this is supposed to be your h value, and this is your k value, and this at the end should be plus k, whatever your k is. So this is going to be -3. So vertex form, just for those of you that have forgotten, is y times a, or y equals, jeez. They must have taken too much blood or something. x minus h, quantity squared, plus k. That is vertex form, where h and k are your vertex. Does that make sense, Nate? Okay. All right, y-intercept. We're looking at the blue. Actually, look at your paper. It might be more accurate than mine, although I think it's the same. What is my y-intercept? 0, -2. You can just write -2 if it asks for it in an ordered pair. 0, -2. Standard form. Ooh. Standard form, you should know, is y equals ax squared plus bx plus c. How can I get that?
Distribute the factor.
Yes, go back up to factored form. You could also use vertex form, but use factored form, y equals x plus 1 times x minus 5, and do double distributive property. Okay? So x times x is x squared. X times -5 is -5x. And then we go underneath. 1 times x is 1x. 1 times -5 is -5. Putting it together, x squared. Combine your like terms. -5x and 1x is, no, not plus, minus 4x minus 5. Now, pay attention. If you had an a value other than 1, then you would have to take and multiply all of these by whatever your a value is. But since a is 1, it's all going to be the same. Okay? Okay? So, in other words, if I had -2/3 out here, you would still multiply these together and get this answer. Then you would have to take this and multiply by -2/3. But since our a value is 1, we don't need to do that. Does that make sense? Does that make sense to anybody out there? Okay.
Yes.
Okay. Are you just saying yes? Yes. Yes. All right. So y equals x squared minus 4x minus 5. Axis of symmetry. What the heck is an axis of symmetry? Martavius, how would you describe it to someone?
It's like the line down the middle where the vertex is.
Yeah, it is the line down the middle that cuts that parabola in half, and it's also the line that will always have the vertex on it. So my axis of symmetry is this line right here. What is that line? Because we have to write down what that line is. It's a vertical line. And on that vertical line, all those points have one thing in common. What do they have in common? All points of the x-coordinate are 2. So the axis of symmetry is x equals 2. Any vertical line you have, look where it goes through, and that is your x equals whatever that value is. Okay? Now, if they do not give you a graph, this is important, because I don't know if we'll get to it at another point. The axis of symmetry is opposite of b divided by 2a. So if they didn't give you a graph, but they gave you an equation, this is also your axis of symmetry. Okay? And, okay, so here it doesn't make a lot of sense, but here you would say your a is 1, your b is -4, and your c is -5. And so if I take 4 divided by 2, that gives me x equals 2. Same way. Okay? And in addition, this Opposite of b divided by 2a also is the x-coordinate of your vertex. Which makes sense because it is your axis of symmetry. Okay, other questions? Does that help on that? Okay, other questions? Don't be shy. Number 2. Well, okay, now my 2 might be different. Let me look on my 2 here. Number 2 says use the table or graph. Let's see if my number 2 is the same. Now that one looks the same, right? Okay, use the table and or graph to answer the following questions. Estimate the zeros. Okay, so looking at the graph, are our zeros at the intersection of lines? They are not quite, are they? Here are my zeros. So we have to do some estimating. And if they were my zeros, if they were exact and given in the table, what would show me that they are a 0 in the table? Guys, listen to my question. What would this table look like? What would I see if my zeros were labeled in the table? If they're on the x-axis, what is going to be 0? The y. But there's nothing with a 0. But that's another way to tell, okay? So it says estimate. You see here, if I get up really close, okay, here's halfway. And this looks like it's halfway between 8.5. Between 8 and 8.5 is going to be what? 8.25. So I would say this is 8.25. And looking at the other one, I would say here's halfway, and it looks like it's about halfway between 0.5 and 1, which is going to be 0.75. I mean, estimating is estimating. That's all you can do at that point. So everybody see how we pick those? Okay. Estimate the vertex. Lovely. This one's not on a line either. It's got to be in the middle. I'm saying it's right here. So x-coordinate first, what would you say that is? 4.5 or 4.50. And how far down is that? I would say it's a little over half. I'd say half is there, so I would say it's between 4.5 and -5. So I'm going to say -4.75. So that would be over here. 4.5 and -4.75. Okay? All right, estimate the y-intercept. Y-intercept. Y-intercept, where do I find that? On the y-axis, or when x equals 0, but we don't have x equals 0. So right here, what is that point? 2, or if you write it as an ordered pair, 0, 2. When does this function equal to? When does the function equal to? When we say function, what are they talking about? What are they talking about? When I say when the function is 2, what equals 2? Yes, when y equals 2. So when the function equals 2 is when y is equal to 2. The y coordinate. So looking at your graph, actually, sorry, looking at the table, where is this function equal to 2? Okay, 9, 2 is 1 point. And what else? Right. As you look at this, here's when your y is equal to 2. I know. So 9, 2 right here and 0, 2. But when it says when is the function equal to 2, that's when the y coordinate is 2. Okay? All right. Oh, use the table graph to answer the following questions. All right. So you didn't have to label those, but I was. When does, we just did that. When x equals 9, y equals, okay. On the graph, identify vertex, roots, y-intercept, and where the function. Okay, so you would just write those in. This is your vertex. This is your root. This is your root. Vertex, roots, y-intercept right here. Okay. And where the function equals 2. How did I label that? Okay. I guess you could point to it and say function equals 2. There and also here. Okay. Any other questions on number 2? Okay. What else do you have questions on? Okay. Number 3. Is that the one that says rewrite the following in vertex form on yours? Okay. Hint. Complete the square or page 112. Identify the vertex and y-intercept. Let me just see what I did here for a second. Okay. So, completing the square. Oh, everybody's favorite, right? Okay, so before you complete the square, what you need to remember are a couple things. 1, we're going to move the C value. C value has to be moved, okay? Because we're going to find the perfect square. And number 2, this only works if A is equal to 1. Okay? It's only going to work when A is equal to 1. All right. So, I've kind of gone back and forth. I still don't know exactly which way I feel is better. But this is what I'm going to do this time. How did I do it here? I did move it, but then I moved it back. Okay, so what is my C? First of all, do I have a greatest common factor? I do not. I do not. What is my C value here? 8. So I'm going to move 8 to the other side. How do I move it mathematically to the other side? Subtract. So subtract 8 here, subtract 8 here. 8's cancel out. This, you essentially are turning into 0 because we're trying to find out what our roots are. So this becomes negative 8 equals 3x squared minus 18x. All we did was move the 8 to the other side. This only works if A is equal to 1. So do I have a greatest common factor between 3x squared and negative 18x? And what is that? Yes, it looks to be 3x, but we only really want to, I know what you're saying, but we really only want the 3. Okay? So I am going to divide by 3, and get the 3 factored out front times x squared minus 6x, okay? It is at this point that we take this b value of negative 6, we divide it by 2, which gives us negative 3, and then we're going to square that. And that gives us 9. This 9 is what I'm going to add down here. And this gives me what I need. Okay? Now, I added that 9 in there. That 9 was not there. Okay? We can't just add something without doing something either to the other side or negating it somehow. But I also have to keep in mind that this 3 out front is going to have to take care of and be distributed with the 9 over there. Okay? So essentially, I didn't just add 9, I added how much? 27. So that means on the other side, I'm going to have to add 27. Okay? And 27 plus negative 8 becomes 19. And that is equal to 3 times this factor squared. Now, I think we talked about this. You take this x, whatever that is, put that x there. You take the square root of this. Essentially, you're taking the square root of that, too. Square root of 9 is 3. And you take whatever operation is second behind your x squared. And that's a minus sign. And you put the little square on it. So x minus 3 squared, if we were to work this out, I'm just showing you, times x minus 3, gives us the x squared minus 6x plus 9. If you work that out and double distribute it, that's going to give it to you. Do you guys want to see that again? What about this one? Going from this to the square of the factor.
So what's the intercept?
There's the x. Here's the minus. Take the square root of that. And then you square it. Okay. So then, got to think what we're doing here. I am going to rewrite the following into vertex form. Vertex form, I'm going to move this 19 back to the other side. So I'm going to subtract 19 and subtract 19, running out of space. And that gives me 19 minus 19, I'm going to put it down here. 0 equals 3 times x minus 3 quantity squared minus 19. That is vertex form. Okay? And I would probably change the 0 back to a y. Y equals 3 times x minus 3 quantity squared minus 19. So what is my vertex? What is my vertex? It's not negative 3. It is 3, negative 19, and the y-intercept. It is not 3. Say it again. What happens with your y-intercept? When you have a y-intercept, what's the x amount? 0. So if you substitute 0 in there for x, what are you going to get? So you have to take 0 minus 3 is negative 3 squared. 9 9 times 3 is 27. 27 minus 19 is 8. So think about that. When you have a y-intercept, you need to remember x is equal to 0. Substitute 0 in there and solve it to find what your y-intercept is. Okay? Let's take a look at B also. Unless, does somebody else have another one now that we've done that? Well, let's just do B. Erase. Okay, so always check first, do I have a GCF? No. It says, rewrite the following in vertex form, complete the square, okay? So, what is my C value in this letter B? What is my C value? 3. So, to move it to the other side, I'm going to subtract 3, and get negative 3 equals x squared plus 4x. Okay? My A value is what right here? It's already 1, so I don't have to factor anything out, but I do need to complete the square. Okay? So that means I need to take my B value, which is 4, divide it by 2, which gives me 2, and then I need to square that, which gives me 4. So I'm going to add 4 right here. If I add 4 to that side, I need to add 4 to the other side. 4 plus negative 3 is 1. And if I rewrite this, that is going to be the square root of the first term is x, plus the square root of this term is 2 to the second power. We're pretty close to vertex form, but I want to get that 1 to the other side. So subtract 1, and I have y equals x plus 2 squared minus 1. That is my vertex form. X plus 2 quantity squared minus 1. So what is my vertex for this problem? Negative 2, negative 1. And what's my y-intercept? Remember, you need to remember x is equal to 0 when you're talking about the y-intercept. So substitute 0 in for x. 0 plus 2 quantity squared minus 1. 4 minus 1 is 3. Okay. Now, you want to know the other way to do that, which I just recalled, which you don't even have to do that. If you are in standard form, you can look up at standard form. That x being 0 is going to cancel that out, and that C value in standard form becomes your y-intercept. Same over here. 0's out, 0's out. That 8 became our y-intercept. Okay, so there are multiple ways to go through that. All right, is there another kind of quick one? Anyone? 9. Okay, solve the system of equations both algebraically and by graphing. All right, so here's the first one. 2x plus 6. That is a, what kind of an equation? What is it? No. 2x plus 6. What kind of an equation is this?
That is not a number.
That is not your number 9? Okay, wait, what's number 9? Okay, use the quadratic formula. Oh, that's the one I was trying to do earlier, I think. It's this one, right? Okay. Use the quadratic formula to find the radical form and the decimal form. All right. Can I use this as it is and find A, B, and C? Joe, come on, head up. Can I use this as it is to find A, B, and C? No, why not?
It's not right.
It's not in standard form, so I need to move the 5x mathematically to the other side, right? I get 0 equals 2x squared minus 5x minus 12, okay? Ooh. So, value of discriminant. What's my A value? 2, just the numbers, My B value is -5, C is -12. The discriminant is only B squared minus 4AC. B squared minus 4AC. So -5 squared minus 4 times the A value of 2 times the C value of -12 gives me 25 minus 8 times -12 is -96, I believe. We need to add the opposite, so I get 121. So the value of my discriminant is 121. That is a positive value, correct? When you have a positive value in your discriminant, how many roots will you have? 2. Okay. All right. Radical form. So I'm going to write this over here. So opposite of B. B is -5. So x is equal to +5 plus or minus the square root of parentheses -5 squared minus 4 times A value is 2 times C value is -12 all over 2 times my A value of 2. X equals 5 plus or minus 25 minus 4 times 2 is 8. 8 times 12, 96. Is that right? Oh yeah, we just did that. -96 plus a positive all over 4. X equals 5 plus or minus. If you recall, this is 121, so I didn't have to do that. The square root of 121 is 11 divided by 4. That gives you, if you add 16 divided by 4, which is 4, if you subtract -6 divided by 4, which is -3/2. So in radical form, x is equal to 4 and -3/2. In decimal form, that would be 4 and -1.5. Okay? Guys, finish up the rest of this review. Come with your questions. Okay? Oh, I'm sorry, what?
How do you find 2?
How do we get 2? If you have, and it was in our notes somewhere, if you have a negative discriminant, there are no roots. If you have your discriminant equals 0, there is 1 root. And if your discriminant is positive, then it's 2 roots. And that is in the book somewhere. Yeah. Okay. I would say I have a couple things tonight, but if you have, how much more do you have some questions on? Quite a bit?
Yeah.
I would say if I send you a Zoom link, or do you have stuff going on tonight? I have a couple of things, unfortunately. I have something from 8 to 9. I have something from 5:30 to 6:30. Maybe we could squeeze a half hour in. Would that be helpful? If I send you a Zoom link, okay. It's probably, I would say, between like 7 to 7:30. Plan on that, and I will try to send you the link, okay?
Yeah.
And then we'll also work tomorrow, and if we need another Zoom link tomorrow night, we can do that too, okay?